We are now moving on to example 2 and 3, which involves graphing exponential functions when your a value is 1. So example 2 and 3, your a value will be 1. When we start example 4 and 5, your a value will not be 1, which that will pretty much be the same thing. We'll just have to do one extra step. But hold your horses, we'll get there in just a moment. So let's look at our equations. So remember, our exponential equations are in the form y equals a times c raised to the x. So you're probably like, Miss Long, how do I know that my a value is 1 in example 2? Well, let me show you how. So I have f of x equals 3 raised to the x. So remember, the c value is always the value that's associated with your variable exponent. So the number that has the exponent is your c value, which is called your base, and a is the number multiplying to the c value. Well, if you see here, nothing is multiplying to your c value. So another way I could rewrite this is f of x equals 1 times 3 raised to the x. Hey, remember, 1 times anything is itself, so secretly there is a 1 hanging out in front of my 3 to the x. It's just not there. You can't see it. So your a value is 1, even though you don't see a 1 there. So just keep that in mind. If you don't see an a value, it's secretly a 1. Alright, so the first step before we start graphing this bad boy is to determine if this exponential equation is a growth or decay, which that's all about your c value. So my c value is a 3. And since that is a value, my c value is greater than 1. 3 is not a fraction, or it's a value larger than 1. That means it's going to be growing. So this is a growth. Holy hot dog. So this is going to be a growth. So our equation, if we go from right to left, should be increasing if we do it correctly. Now, in order to graph this, we need our 3 points, which we always use these 3 points when we graph exponentials. Okay, we always have the point 0, 1. So I'm going to go ahead and plot that one. That one's already done, taken care of. So I'm going to plot the point 0, 1. Plot my lovely point right there. Now the next one, the next 2 values are associated with your c value. So my next point, the x value is going to be 1, and the y value is going to be whatever the heck c is. So c is a 3. It's the value that x is raised to. So my c value is a 3. So my next point I'm going to be graphing is at the point 1, 3. Alright, and my last point is at the point negative 1, 1 over c, which the way that's easiest to see this is basically to find the reciprocal of your c value. So my c value is 3 over 1, which I'll write that over here. That's our c value. And the reciprocal of that, if I were to flip that over, it would turn into a 1/3. Okay, so at negative 1, you always find the reciprocal or flip the c value, and bam, you have your negative 1 point. So at negative 1, it's going to be 1/3, which I'm just going to approximate that since, you know, I don't really have 1/3 graph. So 1/3, it's not quite halfway, it's a little bit lower than that. So I'm just going to put a little point right there. Alright, now before we connect our dots, we have to remember what our asymptote equation is. So our asymptote equation, anytime we have exponential graphs for now, okay, the asymptote equation is always sitting on the x-axis, which is the equation y equals 0. So that's our x-axis. Always. Later on, we'll be doing transformations with these graphs, which will make them move around, and we'll change possibly our asymptote, but we're not there yet, so you'll just have to wait for it later on. So every single time on these problems, our asymptote is on the x-axis, which is y equals 0. So I'm going to go ahead and graph it. Remember, when we draw in our asymptote equations, we always use dashed lines to denote that they are invisible, you can't see them. Okay, so that is the line that our graph cannot cross. Okay, so now I'm going to be connecting my dots. So I'm going to start here the way I do it. I usually start with this point and go up one way. And this one, this way, you get really close to the asymptote line, but you never touch. So, something like that. And of course I have to name our graph, obviously, and this graph's name is going to be Edward the Exponential. Now, before we get done with our graph, we need to find the domain and the range, which I'll show you interval notation and inequality notation in case you are someone that likes that notation. So our domain. Okay, for our domain, we ask ourselves, how far left does our graph go? And how far right does our graph go? So how far left, if you notice, our green arrow is headed to negative infinity on the x-axis for forever. So it starts, or it goes from negative infinity, and it cannot equal negative infinity, so we put the parenthesis. And then we ask ourselves, how far right does that go? Well, even though it doesn't look like it, the graph will kind of get wider and wider. Even though it doesn't seem like it, I promise you it will. Okay, so it will continue on in the positive x direction for forever. So to infinity and beyond with Buzz Lightyear. So that would be my domain in interval notation. Now in inequality notation, remember you have to pick one or the other, so I'm going to separate them. Okay, inequality notation, since we went from negative infinity to positive infinity, we used all of the x values. So that would be where x is all real. We use that funky notation. Alright, so that would be our inequality notation for domain. Now the range, we asked ourselves, how low does the graph go? Okay, which this graph, it gets really close to 0 on the y, but it never touches. Okay, so it gets really close to 0 but never touches, so we don't equal 0, so we're going to use a parenthesis on the 0. If it did equal it, we use the bracket. And then we ask ourselves, how high does the graph go? Well, if you notice, that green arrow points off into positive infinity on the on the y-axis, so it would go to positive infinity. Okay, and it can't equal infinity, that's why you use a parenthesis. Now, inequality notation, 0 is involved, and remember, range is the y, domain is the x, so it's going to have a y, and a 0 is associated in the problem. Okay, so let's look at these numbers in relation to 0. So these values on the y, are they smaller or larger than 0? Well, these numbers up here are larger than 0. So this would be y is greater than 0. Now I'm not going to put an equal to though because it cannot equal 0 because of our asymptote. So you can use either these for your interval notation for your domain range or these for your inequality. Remember, you can't mix and match. Alright guys, so example 2 is done. Okay, example 3 is going to be pretty much the same. So when you start example 3, if you think that you want to try it on your own, feel free to do it and fast forward to the end. Otherwise, you can just watch the entire video. Have fun, you guys!